Ecco qua. Era rimasto. Vabbè. Dopo ci rismettiamo. Accetto, ma va. Marta, se poi dopo vuoi dare questo avviso. Ok. Se dopo vuoi dare questo avviso. Come che me la lascio, non so se lo darò. Some useless things to break home. They send us this. It's not so bad, but the one of the best writing. So I know that. Maybe always thinking about that. Maybe they send us to but we can. Good.
No, I had to leave because my friend was out today, so I was like needing to go out. He was like, so either you're coming out with us or like come home now, so you can go to bed. And I was like, okay. I was like, well, I can't go out. Because I feel like I'm not person right now. I'm so tired. Yeah, I got home and just like got in the pajamas and crashed on their mattress and woke up at like 8 to see my house. Yeah. I have the days where too well issues. Yeah, very much. They still recognize it was like last night because he felt that he needed to sleep more. I need to go somewhere. No. Yeah. Fast walking. Yeah. Yeah, it's like you know that the thought came from the right place. Yeah, he was trying to do a nice thing. It's just it's swollen brain. It makes sense. He also does this thing where he police before he answers questions, which in his head there's no way. Like I'll ask him a question and he'll answer right away. But to me, it's like asking a question. Then you just stare at it for 5 seconds. And then he answers the question. Okay, so I'll ask him a question, he disposes, and then he answers, and I'm like, how do I make this weird? You're like, thinking about it, you must be able to talk about process. Yeah, like I thought it was like a twice plus a task, you know. When I'm like on track, yeah. Yeah. So I need to go.
Good morning. We'll just wait for 5 extra minutes, right? Because I can see in your faces you're still sleepy. I'm still sleepy, so let's wait 5 minutes to see if more sleepy people come in. Okay. Then we start. Since we are waiting, I wanted to take the chance of asking who's presenting this morning? Okay, great. So we have Sven, okay, and David, right? You sent me the slides. Okay. Do you need any presenter notes or is it just PDF or point all good? Okay.
If you remember, my presentation is on Google Drive.
Yeah, let's see if that's
Yeah, I
this
checked
one,
yesterday.
right?
Yeah,
Yeah, I remember.
Yeah.
Let's see if I can. Did you solve the problems with?
Yes, I did.
Let me try it. Okay. Actually, I don't have the link here, to be honest. Let's see. Short. Maybe this one. It's this, right?
Yes.
Okay. Yeah, thank you. So, okay. Good morning again. Thank you for being here. I know that the last day it's not easy, especially if you attended the dinner last night. But I'm happy to see people here. I just want you to go through the program today. So we have the last session, so session on ethical AI and innovation. Then we'll have a coffee break with more food and more coffee, uh, which is great. By the way, if you need coffee, the coffee that's outside, it's not cold. It's also not warm, but it's not cold. I added. It's okay. And then we have a presentation session with Into the Black Box. And then we'll close the conference and have the best paper award. And you'll find out who got it, okay? But right now we'll start the paper session 4. And the first paper, it's titled The Human-Centered Decision Support System in Customer Support. And we have Sven Munker? Okay, great. All right.
Don't ask me what the name comes from.
Okay. Okay. Okay.
We have some kind of pointer, or
We
I
don't
just-
have.
I just click.
Yeah.
Okay. Yeah, it's fine, it'll work. Okay, then thank you for the introduction and thank you all for being here. Since we are talking about democratizing AI, we saw this on a little bit smaller scale, where we wanted to include employees in the development of the decision support system on an AI basis, in our case, in the customer support setting. Why is such a system needed in the first place? People in customer support deal with, on the one hand, an increasing amount of products, an increasing amount of problems, and on the other hand, customers demand shorter reaction times. Ideally, if something doesn't work, for example, yesterday my phone stopped working, and I was really angry that the telecom was not able to answer my question on 10 o'clock in the evening on a Saturday. And that's also down to customer support employees. They need to react fast, they have a lot of problems, and they're just overwhelmed. And all of this results in a lot of stress. And our question now was, okay, how can we create such a system that it reduces the stress on the employee and, of course, helps them make better decisions and answer problems better? The general idea behind this is that every decision is based on some kind of knowledge and a lot of uncertainty, or small uncertainty, depending on the decision. And the uncertainty usually, if a human makes the decision, is covered by the gut feeling of the human. And our question was, okay, how can we use some kind of AI system from historical data to decrease this uncertainty, increase the decision base, and have less subjective influence, and overall better decisions and less stress on the employees. For this, we followed the human-centered design approach. And of course, since we're talking about Germany, everything has a norm. And this is the norm for the human-centered design approach. What's the first step? The first step is that we planned the human-centered, that we planned our design process. One important step in this was the collaboration that we worked in. We had a process engineer to cover all the process insights and the high-level approach to the employees working. We had in our team 2 psychologists, one to get the human perspective of the employees on how they work, what they want the system to look like, and on the other hand, the psychologists to evaluate the system and to measure the stress influence on the employees beforehand and while using the system. And last but not least, me, the data scientists, who made the system in the end. Then we went into the employee's workspace to really understand and describe what kind of application they could need. We followed them, we did day in life off, where we just sat there for a day at their desk and looked at what they were doing and how they were doing it, what problems arose and so on. But we also tried to not only get our perspective of their work, but their perspective of their work by making interviews and doing cognitive walkthroughs through all of their work. Then we specified, based on this, the user requirements. And then we started to develop solutions. And even though here the iterations are set in the evaluation part of the whole process, we try to, especially during the development of the design solutions, iterate as much as possible to get as much feedback from the employees as possible. So what is the working of the employees beforehand? Well, on the one hand, they get an email and they answer it. What happens if they can't answer the email? Then they have a database with historic, frequently asked questions and parts of answers where they can look up. And also the database or all answered emails are stored in this database with the connected FAQ. And that was our approach where we said, okay, we can use this knowledge to leverage their decisions. So how does this data set look like? Well, they have a lot of categories. It's historically grown, and the categories are made up by the employees. So in fact, we ended up with 471 different categories for 120,000 emails. Some of these emails had more than one category, but the median was still 1, the maximum was 6, but we tried to ignore this and only consider emails where we have one category. And on the one hand, we can see that we have a very high variety, which is reflected in the words per email. With an average of 269 words per email and a maximum of 8,500, we had a large variety of very short emails where they just wrote, okay, my device broke down, help me, up to long emails with a lot of history behind it, a lot of settings behind it. Another problem that we tackled is that usually a lot of problems can be solved with a very few number of solutions and vice versa. So we had a lot of emails that could be solved with very few categories. And on the other hand, we had a lot of categories with really low entries. So how do we solve this with a computer system? Well, first of all, we need to somehow make the email, the text, understandable for a classifier. Therefore, we read in the email and then we have to pre-process it. We tried to separate the emails because usually you don't get one email, no, you get the whole conversation. And this you have to split up because otherwise you have a lot of non-necessary information, all the headers, all the headlines, and so on. Then we tried to reduce the variety in words and also in characters by making a lot of cleansing, especially lowercasing and lemmatization. Lemmatization is where you reduce a word to its infinite stem. Then we had to transform the words to numerical vectors, which is done in a process called tokenization. Afterwards, we fed it into a multi-class text classifier. On the one hand, we used statistical and very simple algorithms, like, for example, a naive Bayes classifier. Or on the other hand, we used net-based systems, starting from a simple feed-forward neural network up to larger transformer networks. Because of data security restraints, unfortunately, we could not use GPT-3 and upwards and just the free-to-load systems that we could fully download to our system. Then, as an output, we get a probability distribution over the problem classes, which, after going through a matching table, then are linked to the internal knowledge database of the company. So how does this look like? The raw data was encoded in XML format that we read in. Fortunately, with Python, this is pretty easy. Then we had the splitting, which was quite tricky and unfortunately till the end did not fully work, because the way we had the program in our text files was not very unified. But still, we tried to just get the raw text bodies and only the text bodies from the customers, and especially ignore the answers from customer support employees that they had given earlier. Then we did the pre-processing with all the steps I discussed earlier. And then we had to make a very unfortunate step because the categories that are heavily underrepresented, we cannot classify. And here you can see that we chose the threshold for our FAQ ID, or the count of mails per FAQ ID to be above 1,000, which means that we could only get the 11 most common mail categories. Then we tokenized this in a step called byte-pair encoding, where you start with the smallest possible constituents of words, so usually single characters, and then go upwards up to a certain threshold and see that you have the least number of tokens that can cover most words. Yeah. And of course, we did the train test splitting to evaluate our algorithm on unseen data, and we went with a 9:1 ratio there. So how does this data cleaning look like on a real test? On the left, you can see an example text where somebody has a system with a lot of devices. And as you can see, the text becomes, during our steps of pre-processing, less readable for the human, because we plug out a lot of grammar and all of our nice systems that we use to write text. And afterwards, with the step of tokenization, where you can see, since we went with a very high number of tokens of about, so our threshold for the tokens was 50,000, which was enough to cover most words. As you can see, even the word like weekend is not split up into week and end, but still kept as one word. And then we end up with a fully numerical vector. Afterwards, we feed it into the algorithm, and what comes out of the algorithm is the probability density. And unfortunately, in many cases, humans cannot deal very well with probabilities. So we, in cooperation with the employees, decided to give them a top 3 result. And afterwards, it's still an ongoing process. We want to test, on the one hand, which input or which measure for the certainty of the result they would like best. For the results of our algorithms, well, unfortunately, besides the advantages of the easier algorithms, which are low computational cost, and on the other hand, maybe some kind of easy interpretation, it's just not enough. The context understanding, especially for these males, is too important, so they did not perform well enough to be considered. On the other hand, we had a lot of problems with the heavier things. We tried some BERT models and GPT-2, but both we had to tune down so much that they also did not produce good results, unfortunately. So we went with the RNN, which still 70% precision on 11 categories is not the best of results, but given the data quality that we had, I think it's a reasonable result. And since it's no fully automatic system, I think 90% in top 3 results still can help the human make a better decision. Here you can see an example of the front end. Unfortunately, I cannot show you the front end that's implemented in the company system. This is the front end of a demonstrator that we developed inside this project. One very important point, especially for the employees, is that they are not forced to use the system. They could just click on one of the categories, and then here it says send, but usually, of course, they will get just a text snippet that they can copy over and still manipulate to the customer's needs. But they won't need to use the AI assistant unless they need to or want to use it. If they use it, they get a result, and as I said, here we have different configurations. One of the configurations, of course, could be to give them just the probability. On the other hand, we work with different systems. We also had traffic lights or thumbs up, thumbs down, together with the color encoding, and then they get the result from the system. This is the post-system workflow, which has become a little bit more complicated. One thing that is not included in this workflow, because it would just be too much, is that this is only the workflow if the employee chooses to use the system. So the employee still gets the mail and can just work along the old workflow and completely ignore the system if he or she decides to. On the other hand, if they want to use the system, the email is then transferred to the algorithm, which performs the matching to the FAQ database, displays the result, and then the employee can still decide whether to use or discard the decision of the algorithm, because unfortunately, our algorithm still produces wrong results sometimes. And then they can answer the customer and also manipulate the answer so they don't have to copy the full text. I want to close this with a short discussion, what is human-centered in this design approach? Because, okay, the use case selection, we did a lot of stuff with the employees, we followed their workdays. This could be considered very human-centered. The front-end design, we did participatory workshops where we discussed a lot with them, where they could design their user interface. So this, I would also say, is very human-centered. For the backend development, which was my part, I always asked the question, okay, where's the human-centered part in my work? Because, to be honest, I got a data set, I had a given problem, and then I just did data science stuff with it. But on the other hand, we had frequent iterations with the employees. We got their feedback, we discussed with them about the project. And it did not change much about the system at the end, but they got way more involved through, of course, not only the iterations of the backend, but through all of these steps. And it was not only that it was just a system that they will be forced to use in the future, it became their system. They understood a lot more about the system, and they wanted to use it. They wanted the system to work, which I think is a very, very big improvement for such projects. With this, I want to end this talk. I thank you for your attention. And if you have questions,
Thank you for your presentation. Do we have any questions? Yeah.
Thank you for the presentation. So, if I got that correctly, the task can be seen as some kind of question answering in a certain way, but I didn't really understand that. I didn't really understand what's the. So, do you have the labels of the file? So you're trying to classify that there is no, say, NLP extraction from the database of.
sorry, I didn't get the last time.
So you have, so from what I understood, like you have a list of frequently asked questions.
Yes, we have a list of frequently asked questions, and the overall task, or the task of the backend, is text classification.
Okay, so you're learning on some answer that someone did.
That the employees have given.
Okay.
Yes.
And the other question was, so you said you didn't use like BERT models or GPT. I mean, we tried, but
we tried, but the results, we had to tune them down a lot to get them working on our data set, and that was not sufficient, unfortunately. We have results of like 20 to 25%.
So my question on that was if you also tried some, say, old-fashioned or embedded models like word-to-bag, the non-contextual ones, the new ones like BERT, but the old one, which sometimes they do the trick.
Yeah, no, we didn't try that.
Okay. Thanks.
We had another question.
Thank you for the presentation. I think I was the first part of it was very interesting. I wanted to ask in terms of outcomes, in which way this work impacted the work of the people in the administration.
At the moment, this is an evaluation in the company, and unfortunately, we had a little bit of problems with the implementation there, but we don't have the results yet.
So you tested it, they were testing it.
We are testing it. We have performed pre-tests on the employee stress, and then there will, of course, be performed on one hand T1 and T2 measurements on how they adapt to the system and how they work with the system.
Any more questions? Yeah.
I have two short questions. The first one is, are there any empirical limitations that we have found out? I mean, you were working in the database of more than 1,100 emails, yeah, there's like some empirical limitations that you found out that are necessarily in order that your system will work. And the second question was maybe also connected in some days like emails from a system that also require you to maybe send an image or something like that. Is something that you are working on or considering, or maybe in this case something.
For the second question, we are not working on this. For the first question on limitations, I'm not very sure about limitations, especially connected to the number of emails. The biggest limitation, I would say, is on the one hand, the separation of the different categories, because some emails, despite being in a completely different category, because it's sorted according to products, are written very similarly, and thus the algorithm has problems distinguishing between those two categories. So this is one big limitation, and on the other hand, the biggest limitation is just the underrepresentation of a lot of categories.
Any more questions? I have a question. How do you plan on dealing with that? So do you already have a strategy on how to deal with these problems that you identified, the underrepresentation?
On the one hand, the separation of the different categories, unfortunately, is not in our hand because it's the company that decides what categories they have in their FAQ database and which they don't have. And even if you re-emerge these questions or these FAQs, you'd still have the problem that you cannot trivially sort the old emails into the new categories. So you had to collect the database from scratch on, which I think the 120,000 emails were a collection from the last 6 or 7 years. On the other hand, the underrepresentation, we wanted to try some data augmentation techniques. But especially for text, this is kind of challenging because you cannot go down the same road that you go down the road, for example, for numerical input data, because they can just use averages, for example. This is not possible here. We tried to naively copy some emails, but this did not improve the results and just resulted in heavy overfitting, which is to be expected, I guess.
Do you think that the workers may help in that? I mean, when they get an email which cannot be classified, can you resort to the workers to actually improve what you have in the system? Like resort to their classification in a way?
We have a feedback loop for this, and the biggest improvement, I think, would still be a reorganization of the FAQ catalog, which this system could also help here.
And it would be a great contribution to the company.
Yeah, of course.
Okay.
Okay, that was a question. What's interesting, it's just a point that maybe you haven't talked about when you tested it, the performance of working on how it goes. Like you have like implementing some performance stats about the workers' flow.
We are testing at the moment, and yet we don't have results on how it's influencing the workers. Unfortunately.
Great. We don't have any more questions. Let's thank again the presentation. And then we will go to the second presentation of this session. This is a shorter session, that's why we started a bit later. The second paper is an AI-based remote rehabilitation system to promote access to physical rehabilitation, and will be presented by David Aleixo. Okay. Do you want to try your?
Yes.
Right. Let me see. This is to share the sound.
Yes,
right?
sure.
technology, right? So in the last years, technological tools can be used so that people can make rehabilitation at home. Okay, so in the first phase, they have to go to the hospital, rehabilitation centers, but maybe at home, they can keep on working on rehabilitation. Okay, in this picture, you can see the typical situation where one patient is using a rehabilitation system. Okay, this rehabilitation system, this computer, will be connected to the TV, and they will use a body tracking device so that the system can track the patient's skeleton, okay, the patient's joints. At the same time, the system is supposed to provide multimedia feedback because you want that the patient is motivated, engaged all the time. Okay. Now, at the same time, we can use telemedicine tools. So the therapist, the clinician, can supervise the patients remotely. All right. So if we combine these two ideas, then we can devise a scenario where we can promote the patient's independence. Okay. We want to promote the access to physical rehabilitation. And this is particularly important in low and middle income countries because maybe they don't have access to rehabilitation at all, right? Maybe they live 100 kilometers away from the rehabilitation center. And this is where technology, this is where artificial intelligence can help these patients to gain access to rehabilitation. Now, how do these systems work? Well, at this point, I would like to introduce the first system that we developed. It was called Aglaia, and this is a screenshot of the user interface. Okay? It was a web-based system where the patient can see themselves on the screen, and they make the rehabilitation exercise, and at the same time, they get feedback about it. It is very important that you provide multimedia feedback, as we discussed before, so that they are engaged in the process. You have to think that the exercises are very boring, and they have to do it over and over. Okay? So at this point, we use gamification components so that we can actually engage the patients. Let me show you a short video so that you can see how the system worked and the context in which we developed this system. Okay. Okay, so this is the general idea. This was done back in 2019. This was our first approach. And we obtained funding to keep on working on improving the system. Okay? So in terms of artificial intelligence, we use an algorithm which is called dynamic time warping that can be used to compare or analyze time series. This algorithm was used to, for example, word recognition. Okay, so we did use this algorithm to compare the patient's exercise with the reference standard or the gold standard, which is the exercise properly made by the clinician. Okay, so we essentially compare the position in the 3D space of the joints involved in a given exercise. Okay, that's all. So this was our first approach, but we felt that we must focus on usability because when we test the system with real patients, they were happy about it, but we had to give them a lot of feedback and we had to guide them. So we felt that usability was an issue. Okay. So in the second iteration, the second system, Virtual Physio, we changed some things. For example, we decided to go with a virtual environment. Okay, this is what the patient will see on the screen. Okay, we use a virtual avatar that mimics the patient's movement. For example, if the patient is making this exercise, then the patient will see that the avatar is doing the same. Okay. Again, we use an external body tracking device to capture the body joints information. Okay. And we also decided to integrate what we call exergames. Okay, exergames are like real-world movements that the patient can make, and they feel that they are doing something closer to the real world, but in the end, they are doing physical rehabilitation. Okay. So, for example, in this exergame, the patient is supposed to grab one object inside a restaurant, the virtual restaurant, and move it to a different position in the 3D space. Okay. I think this is a good decision because when patients make exercise, they don't want to do boring exercises over and over. They want to do real-world actions. For example, they want to play in a virtual kitchen and they want to move objects from one point to another. Okay, so this is an improvement that we introduced. Also, we decided to design this black box device where we integrated a small computer and the external body tracking device. Okay, usability was a problem in the previous system, so we wanted a system that you can connect to the TV and that's all. Okay, so this was the idea. At the same time, in terms of using automation, artificial intelligence, we created a data model, and we created a language so that we can define exergames in a programmatically way. So what we did was to create a simple language, like a programming language, and by using this language, we will define the different components of the exergame. And then, thanks to an automated process, we could automatically generate the exergame. So for example, if this is a different exergame, the patient cleaning the window, we use the language that we created to define the different components of the exergame. For example, a visual component to render the number of repetitions, the score, some components, some simple components to add visual information, and more importantly, the actual information of the movement. In this case, for the movement, we define the instructions to specify the key points of the exercise. Okay, so we did that with a language, and then we run scripts to actually generate the exergame. Okay. And finally, this is our latest system, Physiogalenus. And why developing another system? Well, again, we felt that the previous systems, they were not very accessible. They were not scalable. Okay, because in the end, the patient must buy a system that maybe costs like 2,000 euro, and this could be fine for hospitals and rehabilitation centers, but maybe this is not an option for patients at home. Okay, so again, we develop a different system. We use a different technology, and this is the result. So in the second system, virtual physio, we have a small computer, but this computer requires a dedicated graphics card. Again, we need a body tracking device. Okay, so maybe the system, you need to invest €2,000 to do that. Okay, so with this system, we only use web-based technology. Okay, so the patient doesn't have to install anything, the therapist doesn't have to install anything. Okay, and you can run it on any standard computer with a webcam. You could even run it on a smartphone. Okay? So instead of using an external body tracking device, we use a technology which is called MediaPipe Library, which is a library developed by Google. And with this library, you can carry out the tracking process by using just a simple webcam. Okay? Now, at the same time, we wanted to focus on the therapies because in the two previous systems, we focus on the patient, but we think that the therapist is also essential. Okay, so we started to think how we can save the therapist time. Okay, and well, in this situation, we thought how we can automatically generate or modify the rehabilitation routines specified by the therapist. Okay, so we started to use artificial intelligence in a more extensive way. So at this point, we have two different applications. Okay? The basic application, like the one that you saw before, the therapist application, which is a web-based application where the therapist can define the exercises and the rehabilitation routines, and everything is connected through a cloud-based layer. Okay? Now, two important modules that I would like to discuss today. The first one is what we call the recommender system. Okay? With this module, the system can automatically generate rehabilitation routine. Okay? With this module, the system can automatically modify rehabilitation routines depending on the patient's progress. For example, if one patient is making really well, maybe it makes sense that the system recommends a more challenging rehabilitation routine. Okay? So this is the goal of this module. The second module, that is called Explainable AI module, is about justifying why the system made the recommendations to the rehabilitation routine. And this, I think, this is very important because in the end, the therapist will have to validate the modifications made by the system. We are not trying to replace the therapist. We are trying to provide a tool so that in the end we can save the therapist's time. So in the end, the therapist will be responsible for the final modification of the rehabilitation routine. And to do that, the therapist will have to analyze information that the system used to actually modify the rehabilitation routine. We think that this is very important. Okay, so this is just the use case because in the end, the therapist will be the one, as I mentioned before, validating the rehabilitation routine. Now we have used two different algorithms to do that. You can check it in the paper to analyze the details. But very briefly, the first one is about the automatic generation or modification of the rehabilitation routine. To do that, we use a variable which is called performance. And it's quite simple. If the performance of the patient is better and better, then we can modify the routine to introduce more challenging, more complex exercises. Okay? To do that, we use fuzzy logic, which is an extended version of Boolean logic. And with this tool, we can, let's say, compute with words. For example, the therapist won't say, okay, this patient made 7 repetitions of this exercise and the patient spent 47 seconds in this exercise. It doesn't work that way, right? The therapist will say, okay, the patient made a high number of repetitions in a short time. Okay, they use labels. Okay, they deal with uncertainty. They deal with vagueness. So that's why we decided to go with fuzzy logic. because with fancy logic, you can compute with words. Now, the second algorithm is about the generation, the explanations made by the system. Okay, so basically, you have the details in the paper, but basically, we are using now if-then rule-based system, and to find out why the system modify a specific rehabilitation routine, we check the rules that are triggered depending on the patient's performance. So this is the general idea. Of course, when you deal with a therapist, you have to provide visual explanation. You cannot provide text. You have to provide some kind of high-level explanation so that the therapist will know if the rehabilitation routine must be modified or not. Okay, so some screenshots of the visual information that the system can provide, and essentially you can see the variables involved and why the system modified the rehabilitation routine. For example, the number of repetitions or the time involved in a given exercise. So what's next? Now we have a system that is more scalable. It uses artificial intelligence. It can automatically modify the rehabilitation routine. But at the same time, we have a previous system that maybe is more suitable for hospitals and rehabilitation centers. Right now, we are trying to put everything in the same place, and we are trying to personalize rehabilitation for every specific patient. Okay, this is one research line, and the other one is about using the technology and the algorithms on different projects with patients affected by different neurological conditions. For example, patients affected by a spinal cord injury because they require physical rehabilitation. And this is another project that we are running right now. You are going to see a classical exercise which is called box and block, right? So let's suppose that we can use these algorithms on this project, and to do that, again, we can automatically modify the rehabilitation routine. Again, the clinician will be responsible for validating or not the modifications made by the system. So the technology is different, but the problem, I will say, it's more or less the same, because in the end you have patients. The performance of this patient will be different along time, and maybe you want to automatically modify the rehabilitation routine depending on the patient's progress. Okay, so I think same problem, but a different context. Okay, you have more information if you are interested in this work. These are the most recent publications about using artificial intelligence on these kind of projects. So you are welcome to take a look at them. And that's all. Thank you very much for your attention, and I will be happy to answer any questions you may have. Thank you.
Do we have any questions?
Two, actually. One is about privacy and security aspects. What are the, can you compare the difference between the two systems? I'm sure this is something you talk about a good bit about the web-based systems. And another question is about physical therapists. You said you were getting their feedback. What have you learned about? I mean, it's a very different kind of job for them. How do they like the system?
Yeah, thank you for the questions. About privacy and security, we are working on that. I mean, I think that from the technological point of view, we are covered because we've been working on this for a very long time. But at this point, we are trying to get more funding to provide a holistic approach. Okay? In the end, you will need not only patients, but also therapists, You need to think about the ethical aspect, of course. You need law experts, right? So we are trying to do that from a general point of view. Okay. And regarding the second question, yes, we've been working with therapists, but we have not run yet longer clinical trials. Okay, so far we've been running preliminary clinical trials, and our next step is to run a trial, let's say during 6 months, 1 year, so that we can actually assess or evaluate if this has an impact on the patient's rehabilitation process. Okay. Last year we tried to get some European funding. We didn't get lucky, so we'll keep on trying. Thank you.
Any more questions?
Maybe following Sally's question regarding, so this is very good to like focus on the patient, but then looking at the other side, like the therapist, for example, and then following up on her question, I know that you said you are, you don't want to replace the therapist, and I understand that that's short term, but how do you see that working out long term? Do you have any concerns regarding how maybe therapists could maybe either be replaced or also the nature of their job could change? And I mean it as a very quick question, like just if you thought about it and how, whether you have any concerns.
Okay, so the question is about the impact of this technology on therapists,
Yeah.
right? Okay, when you work with clinicians, it can be very tricky because you discuss with them a technological tool and maybe they feel that there is a risk involved in that. Okay, it's a challenge for them because suddenly they think that they can be replaced. Okay, I think that's not the case because in the end, this is a tool that they can use to provide better rehabilitation. Okay, to spend quality of time with their patients. So that's a challenge, of course. And when you talk to them, it depends on their profile because some of them are very excited about using technology, but some of them will say, whoa, stop. Please discuss the implications, the long-term implications of this technology, and let's see how we can deal with that. That's why it's very important to find or to deal with some kind of co-creative approach between patients, computer scientists, and therapists. It's complicated, I will say, and it depends on the therapist. Yeah.
So thank you, it was very, very interesting.
Thank you.
And thinking about the impact, I mentioned that, of course, the role of the physician looking like changed so much, but I mentioned this as a support for the large number of patients, maybe. So, that is like my thought about that. And if we mention, as said, this as a support to save time and to enlarge the number of patients that can be followed by very well by this system. Which are the targets that you mentioned can easily access to this kind of system to have that rehabilitation?
Well, I would say that the target, the real target, are the physicians, the clinicians. Okay, because in the end, someone will have to supervise the patients, and someone will have to guide them through the process. Okay, so in our experience, it makes sense that in the first steps of the rehabilitation process, you can use technological tools, but you have to be face to face with the patient. Okay, so maybe you start in the hospital or the rehabilitation center, and you use technology with your patient in the same place at the same time. Now, in the second step, maybe you can start using technology at home, and the patients can use the knowledge that they obtain in the hospital or the rehabilitation center. So this is the general idea. From the commercial point of view, if we think that way, I think that the target should be the therapists, the clinicians. Okay, and it is very important what you mentioned. With this technology, you can supervise more patients at the same time, because in many countries, I know for sure that there is a lack of physicians, and that's a problem. This is an unmet clinical challenge. So maybe using technology, one clinician could supervise multiple patients at the same time. I think that makes sense. Thanks.
Any more questions?
From the patient point of view, did you measure us in some way if, for example, this can also speed up the rehabilitation curve? It's faster for them to get back to normal functioning.
Yeah.
And also that in some way can reduce the dropout rate, which I guess is not a big deal. I mean, rehabilitation is something more serious, so I guess it's low maybe the dropout. It will stop rehabilitation at some point, but if this can also decrease that.
Okay, thank you. The question was about if we have measured whether the patients recover better when using technology, and the second is about dropouts, right? So it's an interesting question, because when you introduce technology and when you introduce some kind of gamification or the social aspect of that, they start to they start to think about rehabilitation as a game. Okay, so they get really motivated. You can go to the hospital or the rehabilitation center, and they actually compete for getting the better score in one exercise. And this is very good for them, because in the end, if, for example, in the stroke case, if they want to regain mobility, it's important that they do the exercises properly, but it's more important that they do exercises on a daily basis. Okay, so if you can do that, I can tell you that the rehabilitation process and the recovery process will be accelerated. So they will get back their mobility in no time. Okay, and about the dropout rate, we haven't measured that, but to be honest, so far, when they use technology, they get really motivated, because they are used to traditional rehabilitation exercises, and it's doing the same over and over with a person in front of you. Okay, but if you can see yourself on the screen and you get points, you get a star, you have a ranking, then I think that's better, and the dropout rates will be improved. Thanks.
Any more questions? Great, then let's thank the speaker.
Thank you.
And this closes this paper session. And so we'll have a short break. Hopefully there's food outside, right, Angelo? Yes? Okay. Food confirmed. Okay. So see you in a few minutes. Just 30 minutes, yes. Yeah. Okay. Enjoy the food and the coffee. You have more slides. This one. I'll just put it.
Oh, yeah. I heard that. I did think that mistake last year, I said I was in class. And I said that right next to it, fully passed. That's right.
So I'll close this section.